Hey, this is Sleeper. Welcome back to my channel with another module from Hack the Box Academy. I thought this one would be interesting, the learning process module. It's got some good reviews down here. So, let's go ahead and get started. If you need access to Hack the Box Academy, you can check it out with the link below. Definitely recommend the Silver Annual Plan as it gives you access to all the modules up to Tier 2, all the job role paths, and includes an exam voucher good for 2 exam attempts. So let's go ahead and start. Learning process. Way of thinking. The field of information security is massive. It would be impossible for anyone to learn everything. Let us take the following example. Imagine you want to become a programmer, and you know that there are more than 200 different programming languages that can be used to create applications that can be cracked by debugging or reverse engineering. If we learned every programming language within 100 hours, we would spend 20,000 hours or 2,500 days, 8 hours per day. Or, in other words, almost 7 years to learn all of these programming languages. As a result, we spent 7 years learning all these languages and never tried to debug or reverse engineer the program we created. Great. Let us spend another 7 years learning to debug and reverse engineering. We've got the idea. No one wants to spend so much time on just one area. Furthermore, this is not necessary. We will need some time to learn different technical principles, structures, and processes, but we will not need to spend 7 years. Every programming language has its own strengths and weaknesses. Also, if we can obtain a deep understanding of a single programming language, we will learn others much faster. We do not need to learn every programming language to understand how to read their code. All of them follow the same principles which R.D. Tennant initially defined. The principle of abstraction, the principle of correspondence, and the principle of data type completeness. In information security, we have to learn and understand these principles, structures, and processes quickly. Additionally, we have to adapt our knowledge to the various environments we encounter. We'll have many situations where we will not understand how it works. That is good. At this point, we have to find out what we don't know. More about that later. There are many learning-focused information security communities available to us. Many of these communities provide free reviews of tested applications, vulnerable machines, and guides to help each other and improve their members' skills. When we speak with the other members, we will notice there are generally 2 types of people: those that do not know anything, and those who think they do not know anything. This can be very frustrating, and this is a normal part of the learning process. Communication within these communities should be respectful, always keeping in mind that we all started with 0 knowledge in this field. This is a critical point of success for the community and everyone learning and working in this field. Within Hack the Box, we can use the forum and Discord server to interact with the community. Another important point is our knowledge level. Many people do not know their actual skill level and knowledge level. This is a complicated topic because penetration testers must have a deep understanding of a wide variety of technologies. As previously mentioned, the problem in this field is the sheer volume of information available to us. We can learn about every topic and still not master any one area, or we can learn about just one topic and become an expert in it. Another option is developing our research methodology. the learning process, and how to use this to improve our knowledge. We will be successful if we know how to search for the required information on the internet, and we know how to learn fast and adapt it to the environment we are working in. However, before we can do this, we have to learn and practice how to do it. We will become a good penetration tester only through considerable practice. There is no other way to improve our practical skills. For example, we can read 50 books about programming and we will understand how to read the code. This is the process of passive learning. This can be useful. However, if we need to write our own program, we have to practice active learning, which means we have to write code and test it on our own. One of the most common questions is, when is a penetration tester good enough? We know that one person cannot know everything. In this case, we have to learn how to find, choose, and adapt the information we need. Right now, we are considering these 3 key terms. There is one key term missing. Which key term is missing from the above list? The crucial missing term is learn. The process of learning how to learn is not easy. Most people have never truly learned how to learn effectively. For example, in school, our teachers discussed some topics with our class. First, teachers show us just one way to solve a problem. They explained one way to solve a problem, and after that, they gave us exercises to practice further. Let's take a closer look at the problem. Look at this simple math equation and try to solve it. 20 times blank plus blank equals 65,535. This equation is easy to solve, but did we think about how many different ways there are to solve it? Optional exercise. Ask yourself why you didn't solve the problem in a different way. Write it down and try to think about the reasons for choosing the method that you chose. Take as much time as you need before you continue. Thinking outside the box. What limitations were you given for this exercise? None. So why didn't you think to add more digits or to replace the given arithmetic operations? Welcome to the hacker's way of thinking, called outside the box. So why didn't we think like that? During this learning path, we will acquire more information that will help us find an answer. However, first, we have to understand the way of thinking we currently use. Make it clear. Try to understand what we have to work on. Optional exercise. Why didn't you consider changing the arithmetic operations? Why didn't you think to add more digits? Try to answer as detailed as possible on your own, and try to write about it in at least 200 words. Occam's razor. Thinking outside the box helps us cross imaginary boundaries and thus to access possibilities and options that were not recognizable to us at first. Thereby, we will encounter many options, and the whole way to the solution of a problem can become very complicated very fast. The Occam's razor principle is beneficial for simplifying these circumstances. Occam's razor is one of the central principles of modern scientific theory. The principle is based on the following definition. The most straightforward theory is preferable to all others of several sufficient possible explanations for the same state of facts. In other words, the simplest explanation is always the most probable. For example, we can assume that our computer has stopped working. There could be many reasons for this, as we can already imagine. It can be because the power supply is faulty, CPU issues, or maybe even the motherboard is fried. With such or similar problems, we automatically start to list the possibilities of what could be the reason before we start to solve the problem. Many people work by the process of elimination. They eliminate the probable possibilities that could be responsible for the problem. This approach already leads us in the wrong direction and results in considerable effort to solve the problem. With this type of approach, most people would start by taking their computers apart and checking all of their connections. They are looking for the most likely cause, but ignoring the simplicity factor. After all, the question we should be asking is, why is our computer not getting power? When we ask this question, we automatically form associations in our mind that have to do with the word power. In this approach, the first thought is usually focused on the power supply. The power supply regulates the power for a computer. Therefore, most people's first thought is that the power supply has a defect and is no longer functional. Nevertheless, let us not forget to think outside the box when we think of power, because if we set ourselves the limits that it can only be our computer, we limit our options considerably. If we leave these limits, the first point of contact from the computer is the connected socket and the multiple plugs. If we follow this approach, we would see that our multi-plug had been switched off. Therefore, the computer had no power to start up. So in this case, the most straightforward explanation was also the most probable. Occam's razor in practice. Using Occam's razor in theory sounds easier than it is in practice. We can state that the simplest explanation is the most probable. However, the fact is that apart from that, it is not always so. We must also distinguish between the individual details and mechanisms and the general picture or concept. In our learning phase, and thus also during our penetration tests against companies, we will encounter many situations in which we learn something new. However, it is crucial to understand the overall concept rather than the individual steps involved. For example, once we are familiar with SQL injection and how it occurs, we may find the individual steps difficult at first. However, once we understand the overall concept, it will be easy for us to discover when an web application, is vulnerable to SQL injections. If we have already dealt with SQL injections and know how they can look, we also understand that the individual steps to detect and exploit them can be very complicated. Nevertheless, what remains the same is the concept. The concept is the main focus when learning new topics. Another example is the approach to penetration testing, which is very common throughout the cybersecurity community. Everyone discusses the cases that can occur and how best to approach them. Let us think back to Occam's razor principle and think outside the box. Anyone who has done at least 2 or 3 penetration tests will find that each one is unique. Even if the same systems are used for the clients and servers, their configuration is typically unique. The unique aspects are the stages in a penetration test, which we can learn more about in the penetration testing process module. The simplest explanation for the best approach to penetration testing is that we work with the information that we get. The unique techniques of how we get and use this information are, again, individual steps followed and not the whole concept. The same applies to most exploitation attacks and individual steps for them. Once we understand the overall picture, adapting to the given situations and conditions is much easier. However, suppose we have only learned the individual steps. In that case, we will have difficulty adapting them to new situations, because we do not understand their impact on the systems and their applications. Later in the process, we will see this phenomenon again and again. Once we have identified the solution to the problem, the process and the steps required to achieve it seem pretty straightforward in most cases. Looking back, it always seems easy once we know the solution. The art, after all, is not to get some flag, but to find the way to it. Talent. We all know one or two talented people in our circles of acquaintances. These are people who, in our opinion, bring incredible performance in one area or another. Most people believe such talents and abilities are innate, and that these people have strong skills in these areas due to their genetics or other intangible factors. Besides the fact that genetics influence our thinking processes, talent itself is not innate. The ability to solve particular problems with excellence results from thought processes developed primarily in early childhood. Children can develop such a talent much more effortlessly than adults. This is because they have not yet developed complicated thinking and do not have complex hurdles to overcome. In other words, children typically do not overcomplicate things like adults do. That's true. There is no precise definition of talent, because the official definition is that talent is a natural aptitude or skill. Natural in this sense means that it exists in or is caused by nature. Nevertheless, it cannot be valid if we consider it carefully, because this would have to apply to any skill. Then let us ask the following. Who among the several million students of Hack the Box can naturally fly an airplane? Starting and taking off an airplane requires considerable technical knowledge, which differs based on the type of airplane. Maybe there will be one who, with luck and without knowledge, manages to start the plane and drive with it a few meters, but taking off requires knowledge of the controls in physics. No one knows how to fly an airplane naturally without considerable training and practice. This definition leads us to believe that masters of their craft are born. This is a misconception that comes from the interpretive ability of humans that we must abstract from. However, in summary, talented individuals are defined as highly efficient and perform exceptionally well in their individual fields. Such talents, or rather the ability to solve specific problems and challenges with high efficiency, arise from the constant or persistent confrontation with the corresponding situations and the problems that arise. However, it does not have to be precisely the one situation to develop talent, but rather the thinking pattern to solve problems. The confrontation expands the so-called comfort zone and repertoire, which allows us to think more easily and tackle the challenge or problem. In essence, talent is a trained and adaptive thought process and the associated thought patterns for specific fields and situations. However, we know that we have a good influence on our thought processes and thought patterns and can influence them according to our decisions. This means we can develop and train such talent for any field we want. We should keep in mind that we are not born with our talents or skills. A newborn baby will not suddenly start speaking in 5 different languages or explain to the doctor which laws were not adequately followed during childbirth. However, if we have a guitarist who has been playing guitar for years, it will be much easier for that person to learn to play bass guitar than someone who has never played a string instrument. Nevertheless, let us take a slightly more complicated example where the differences become much clearer. Even a drummer will find it easier to learn to play bass guitar than someone who has never played a musical instrument. Drummers have a great sense of rhythm and emphasize certain parts in each measure. Good drummers keep the rhythm for the songs played and highlight and support the other instruments and vocals with different combinations and variations. Thus, a drummer has already learned many skills needed to learn bass guitar. The drummer will then focus on completely different skills that an inexperienced student has yet to develop in learning to play bass guitar. If we put the drummer and the inexperienced student in the same room, the drummer will be perceived as talented. Developing talent in childhood often depends mainly on the parents and how they encourage their children. If a child enjoys something, or at least is presented as fun by the parents, and the child engages with it, it learns to deal with the given situation. This opens up new possibilities for the child, and new thought patterns are formed, which will be followed by the thought processes first. To understand how these thought processes develop, we would have to deal in detail with psychology and neurology, which goes far beyond this module's scope. However, the important thing is that we influence the development of our thought patterns, thought processes, and thus also our talents. We consider someone as talented when they learn something new quickly or grasp its functionality. Calling someone talented is basically a status assignment. We consider all our students talented even if we don't know what their talents are. Even if we don't know their talents. However, we understand that any kind of individuality in our students' thinking patterns will help them solve different situations in a way that will bring out their talent. In most cases, our students will inevitably discover for themselves what their talents are over time and practice. The problem is that the variety of situations that arise is so extensive that it is difficult to identify these talents in penetration testing. Oh, here we go. So here's actually a good place to stop for today. We'll continue with the learning dependencies in the next section. So once again, my name is Sleeper, and that's a wrap. Until next time.